Hello, everybody. My name is Jeff Abramson, and I'm going to talk for a little while here around ICRA compliance and air quality. We um, we talk to a lot of customers, and there's confusion out there. So if you're one of the confused, you're not alone, and hopefully we can help here with some of the information we're going to present here in this material. This is a encore recording of the presentation that was given at the WSHHE Fall Conference in October of 2024 in Washington State. My name's Jeff Abramson. I'm responsible for engineering and product activities at Omni CleanAir. Omni CleanAir is a air filtration and abatement company that's been around for over 30 years. We're headquartered in Mukilteo, Washington, so that's about half hour north of Seattle, for those of you that are familiar with the area. We've been manufacturing industrial and commercial air filtration equipment for over 30 years. And our intent is to keep anybody who's working in these spaces safe from hazardous pollutants and particles, the people working as well as the occupants of the space. And there's a huge number of applications. We're going to specifically talk about construction here in healthcare environments today. Around infection control primarily. Here's my contact information. If you have any questions or comments, please don't hesitate. So the presentation today, I'm going to cover three topics. The first is I'd like to kind of describe, what a portable air scrubber is and what a negative air machine is. And some of you watching this may be familiar with it and others may not. A portable air scrubber, in simplest terms, takes the dirty air in and produces clean air out. And these are two examples of negative air scrubbers, or sorry, portable air scrubbers in our environment. Our company manufactures. The guy on the left is your very standard industrial looking high capacity air scrubber. And the product on the right there is more of a commercial unit that is suitable for occupied spaces. And but they both basically do the same thing. The idea here is you have dirty air coming in, and on this diagram, it's coming in from the left. Dirty air comes in. The first obstacle the dirty air hits is called a pre-filter. It catches very large particles, which basically extends the life of the more sensitive filter behind it, as well as the motor. And so that's what your pre-filter does. The HEPA filter is your high efficiency particulate air filter. It is large. It has a large capacity and capability to capture particles of nearly any size. And a good HEPA filter will capture close to 100% of the particles that are going through it. And we'll talk a little bit more about that in a moment. The clean air then exits on the right side of the HEPA in this diagram and gets pushed out the right side of the machine through this motor powered blower. And the other point that's mentioned on this slide here is that there's a lot of tuning that's done on these machines when they're done right to make sure that the airflow, the size of the machine, the size of the HEPA are all paired up properly so that you get the maximum airflow of clean air going through the machine. Okay, conceptually not that difficult when you think about it, right? Dirty air comes in, it goes through filter, it gets pushed out by the motor. By the way, this could also be in the other direction where the air gets pushed through the filter by the HEPA. And we, for example, have machines that do it in both directions. Okay. One of the most common uses of a portable air scrubber is to configure it as what's called a negative air machine. And the idea behind a negative air machine is that if you want to do some work in a contained space, for example, you've tarped off or sealed off some space where you're doing some demolition, and you've sealed it off because you want to make sure none of the debris escapes the area. You might have a customer clients on the other side of the doorways. You may be pulling stuff from the ceiling, and you may have a sensitive area above, for example. And in those cases, you're going to create a barrier, some sort of barrier around the space that you're using. And that barrier might be hard walls, it might be some sort of sheeting, curtaining type material. And the idea is you will seal up the area using this containment material. You'll put the machine inside the space, and you'll exhaust the clean air outside. And when you do this, what this does is it creates what's called a negative pressure inside the machine, or sorry, inside the space. And this negative pressure will prevent any dirty air from leaking through any leaks you may have in the containment space. And so as shown here, you got your dirty air and your debris inside this space. Only clean air comes out in the space here, and there's no way hazardous material might leak through. And when you have a containment space like this, it's common to measure the pressure differential between the two spaces. And that way you can know that you're maintaining a lower pressure inside the space using this device, which actually may trigger an alarm if, for example, you turn the machine off or the machine stops working for some reason. And so we talk about the negative air machine because it's a key factor of doing any sort of restoration or remediation or renovation work in a healthcare environment. The main tool that I'm talking about here in this second section of the presentation is what's called the Infection Control Risk Assessment, or the ICRA. And in healthcare environments, almost universally, this ICRA is used in one way, shape, or form. And if you're responsible, for example, if you're part of a team responsible for doing some renovation in a hospital, and that could be as simple as moving IT wires around because you're adding more cameras, or it could be as complex as pulling up the floor because you're redoing piping or you're doing an add-on or even new construction. You're going to fill out this ICRA risk assessment. And the first step in filling out this ICRA is you have to understand two things. You have to understand, what is the level or the size of the activity that's happening. And again, your simplest activity might be you're just moving wiring or you're installing new wiring. It might mean you're just repairing a very minor water leak, say in a drinking fountain. Or it could be something super big and invasive, like you're completely pulling out walls or ripping out an external wall for renovations. So step one is you figure out what that activity type is. And then step two is you look at the areas that are affected by this work. And that's going to be the surrounding areas. And so, for example, if I take my drinking fountain example, and the drinking fountain is in the hallway, between, the main entrance and the elevators in a hospital, that's a pretty low risk area. But maybe on the other side of the wall is the intensive care unit. And if I'm going to be going through that wall, for example, or there's a risk that I'm going to do something to that wall, I've increased, what we call here the patient risk groups substantially. And so what you do here is you take your activity type and you take your patient risk groups and you do kind of the cross product of those. In other words, if it's a low risk area and a low risk type, then that's a low risk assessment. But if either are high, then it's a higher risk assessment. And of course, if both are high, then it's a much higher risk assessment. And that's what I mean about the cross product. And that's illustrated with this matrix right here. So again, your construction project type here is A, B, C, and D. And in the ICRA, these are, there's rules and guidelines for these, right? You don't just pick, hey, this is a type B. There's a list of criteria here. And the same is true for these risk groups. And if you look at this matrix, you can see that based on the cross of those two, you'll have anywhere from a class 1 to a class 5 type of a risk assessment. And you can see here that your higher numbers here, you can see your level 4 and your level 5 are where you have both areas of higher risk. And so then the question that I would ask here, again, in the context of what we're doing, is there's a bunch of things you need to do in the ICRA, right? You got to have barriers, you got to clean, you have to have the right material, you have to have training. There's a lot of things you need to do. But where do you need to use a negative air machine? And where do you need to do HEPA filtration of the air? This is the question here. And the answer per the ICRA is it's class 4 and class 5. That's the technical answer. However, in talking with many healthcare officials, they'll often use negative air even in level 3 and sometimes even level 2. And there's one customer that we've talked to that uses it everywhere. And it's like, hey, I want to be consistent. I'm going to use negative pressure whenever I do containment, period. And so that'll be, of course, up to you. But the guidelines, the ICRA guidelines say level 4 and higher. Okay. And so I just kind of walk through that on the picture, but let's look at what some of the actual text here is. It says here, if you're containing the area in class 3 or above, you need to keep it negatively pressurized. And that's just to prevent leakage of debris from coming out. However, if it's class 4 or 5, you not only need to do that, but you need to use HEPA exhaust systems, a HEPA filtration negative air machine, like I've shown you earlier. And if you're directing that clean air indoors, then it needs that HEPA filter, and it needs to be efficient at 99.97% or better. What this number means, this 99.97%, it means that the HEPA filter will capture 99.97% of all particles 0.3 microns in size, or it'll do 99.97% or better of all particles, where the minimum is 99.97% of 0.3 micron particles. The spec is written around the 0.3 micron particles. Particles that are both larger and smaller will actually be caught at better than that per how the HEPA filtration works. It's a little bit of more detail that I won't cover here. And there's another comment here about you cannot alter or change airflow pressure in other areas. Like you may have, nearby rooms that are positively pressured or negatively pressured, and you can't mess with those. And then finally, in class 4, you also need to install a device that's outside the containment that allows you to monitor the negative pressure differential in the area. This is often called a pressure recorder or a differential pressure monitor. And there are many different types of devices there. We have one, for example, that has optional alarms, and it has connectivity so you can get text messages, and it has a built-in printer, so it has all these different features that allow you to measure and log your pressure indication. And then, so that's your class 4. And since class 5, I don't have anything here, it also means, of course, class 5. So you're doing class 4 or higher, you're going to need that negative air with HEPA. And if you're doing class 3, you at least need to have negative pressure. And if you're going to negatively pressure your machine, you might as well use a negative pressure machine that's doing HEPA filtration, because then you'll just protect your workers in the space as well. Okay, so that's your ICRA 2.0, kind of the punchline of the risk assessment with respect to air filtration. The last topic that I wanted to cover here is a little bit more about specifications. And although this industry has been around for a while, there's a lot of confusion around specifications, and there's a lot of missing transparency on specifications. And so, for example, here I list a number. This is alphabet soup here on the left, right? And you might look at a product and it might talk about MERV, or it might talk about H13, or it might talk about HEPA. And it's like, how do I know, right? It might talk about CFM, or it might only talk about square footage. How do I know? And I'll give you a couple examples here in a moment. And on the right, this is more of, so this is number one is the confusing piece, and number two is more of the disinformation piece, where a company is trying to make a claim, and so they may falsely, or at least maybe it's not false, but it's certainly confusing around the claims that they're using. Okay, and so I want to talk about a few of these examples here, so that you feel equipped to be able to read these specs and know what they mean. So, for example, this is one of my favorite tweets. Dr. Zatari back in 2021, tweeted this laundry list. Oops, this laundry list of all these fake HEPA things, and I love the list because I'll often see products online, or I'll see catalogs, or I'll see posts, and there'll be something like a HEPA Fast or a Super HEPA or a Maybe HEPA or whatever it might be. And none of these things listed here are real HEPA. And again, HEPA is a very, very specific specification definition, 99.97% particles 0.3 micron. And so this example here, which I found on Amazon here, talks about this hyper HEPA medical grade filtration at 99.5% of all particles. 99.5% is not HEPA per US standards, period. And so you want to be careful and not let something that has the letters HEPA potentially confuse you. You're looking for 99.97% or better true HEPA filtration. Okay. One of the most important things you need to do when you're deciding what kind of machine or machines you need in space is to understand how much air that machine is going to treat. And the common spec that's used for that is called CFM, or cubic feet per minute. Cubic feet per minute is simply how much air is moved through that negative air machine. Is it 2,000 cubic feet per minute, or is it 1,000 cubic feet per minute? And based on how much is moving through the machine and how big or small the space is, you will get some number of air changes per hour in the space. So air changes per hour is simply how many times 100% of the air in the space is treated. So if I want or have 4 ACH, that means every 15 minutes, I'm processing all the air in the space. This is very basic algebra math that we do here. You need to know the volume of your space and how many air changes you need. You multiply those two together and you divide by 60, because you're going from air changes per hour to cubic feet per minute. That's why you divide by 60. And you get your answer of what your CFM that you need. Okay, so for example, if I have an area that's 50 feet by 50 feet by 12 feet, I multiply those three numbers together to get 30,000 cubic feet. That's the size of my space. If I want to have 4 air changes per hour, that means I need to process 30,000 cubic feet times 4 cubic feet per hour. I divide that by 60 to have how much I want per minute, and that's a 2,000 cubic foot per minute CFM requirement, which is a common machine size in the industry to get you around 2,000 CFM. This is really important to understand what CFM means and making sure that the machine you're looking at is accurately portraying the CFM that you're looking for. For example, you might see a spec that talks about, oh, 20,000 square feet or 15,000 square feet. That's a flag, right? Whenever dimensions are square foot only, it means that the testing and the measurements are probably using the minimum ceiling height. And so remember, volume is 3 dimensions, length and width and height. And if you only get square footage, there's a piece of information that's missing. Another issue here is around CFM specifications. You got to read the fine print. You might find out that that's only a bench test with just the motor. Our true CFM specifications are, this is how the machine is tested with the filter and filters that you will get in a real space. And if we say 2000 true CFM, that's what you will get. And that's something that you need to watch for, especially because some products might have the number 2000 in the name of the product. But if you read the fine print, you may find that it's only 1500 CFM. Okay. Watch for quality. I talked about the HEPA claims earlier. Also, another interesting problem is you might see a product and they talk about, oh, this is the quietest machine on the market. Or, hey, this is the smallest machine on the market. Those could just be diversions from missing or false specifications. You also want to look at your total cost of maintenance. You can save some money if you buy a machine that has a smaller HEPA filter. But the problem is that HEPA filter needs to be replaced more often. And so something for you to look at is the total cost of maintenance. And the bottom line is that these large machines are noisy, right? And if you're putting one in a commercial space, you might get complaints. It's something you want to be aware of. But we have found that these machines, once they're in the spaces, they aren't as loud as people think. And occupants, of course, do adapt to this over time. It's white noise of sorts. The bottom line is that the machine needs to do what you want it to do so that your occupants of your space, have the treated air as needed. So with that, I'll finish the presentation. I do please encourage questions to come back to us. Let me jump back to my contact information here. Feel free to shoot me a note or catch me on LinkedIn. You can also reach anybody at the team just going to our website, omnicleanair.com. And I hope you found some value from this.